Here in Utah, we have something called the Bonneville Speed Week, where a bunch of guys with homemade DIY vehicles try to drive over 400 miles per hour. The Salt Flats are probably the most iconic location for breaking ground speed records. This is Super Fast Matt, by the way, but we'll talk more about him later. It's a crazy sport for crazy people, but they all need electricity to run the administrative trailers. And the closest place to get that electricity on the Salt Flats is the sun, and my factory. And normally they're out there running the whole thing with diesel and gas power generators. But this time, for the first time, thanks to Battery Evo and their new power tank, things are going to be quite a bit quieter out there, even if it might move a little slower. It's a nearly 100 kilowatt hour all-terrain tank-tracked battery. This is going to be fun. If a Tesla and an M1 Abrams had a baby, it would be this thing. What do you think?
That's a big battery.
That's a beast.
Even though 100 kilowatt hours is enough to power the average American home for a few days, the power tank won't be enough to power the administrative trailers at the pit unless we can harvest some electricity from the sun to keep it perpetually filled up, which is where the factory comes in. As the closest American-made factory to the Utah Salt Flats, we have to design and manufacture a 14 kilowatt solar array that can withstand 80 mile per hour winds, and we only have a few days to do it. Sponsorships and side projects like these are what help us make the least expensive active manual wheelchairs in the USA, which is the main point of my factory.
Not sure what it's rated to do, but that's like 6,000 to 7,000 pounds that it's pulling right there, so that's pretty cool.
To withstand the weight of 14 kilowatts worth of solar and the force of 80 mile per hour winds, we are pulling our 4x6 3/16 wall tubes next door to be fed into a laser beam. Conveniently, the power tank can also tow 3,500 pounds. Technology has progressed so quickly in the manufacturing space that I don't think people realize how fast we can make things domestically. For this particular tube laser, I walked next door to Oshcut, who knocks this kind of stuff out in a day for anyone who needs stuff really quick. My own tube laser handles the smaller diameter aluminum wheelchair frames, but this tube laser handles the larger industrial dimensions. So instead of us drilling and notching every single frame component, the laser does it all for us within seconds, as long as we have a computer file that the laser can read. One of the ways that we've been able to complete this project in such a short amount of time, or hopefully complete the project in such a short amount of time, is that we've digitally designed everything in CAD first, which is actually a lot easier than you might think. It's obviously a massive structure, but we wanted to be able to park a trailer underneath it. So it has more than one purpose, obviously generating electricity, but being protection from the elements for whatever's underneath it as well. The Komodo is going to be parked right here, so it doubles as a counterweight, depending on whether the wind is blowing in either direction. Batteries are heavy. Nate was able to throw together a rough draft of the structure within a couple hours. What's nice is, since we're a SolidWorks partner, you can get access to the full suite of SolidWorks software for just $48 a year. Plus, if you use the code JerryRigEverything, you get an extra 20% off. And honestly, it is a skill set definitely worth having because there is a massive shortage of people who are able to design things in a 3D space. And the more designers we have, the more people who can use CAD, the better. Less than $50 a year is wild. Plus 20% off, link is down in the description. Now let's get this thing out of here. Even though our pipes are now all laser cut and notched, in order for us to get the solar set up on the remote salt flats of Utah, it has to all be bolted together, which requires some prep work with the welders on our end. What's crazy is that even though welding takes an extreme amount of power, this battery, the power tank, is overkill since it can power about 10 welders all welding at the same time. You can run a factory off of this thing. The power tank can output 22,000 watts at a time, which is about the same as an entire house, meaning it's got 3 240 volt plugs, 4 110 volt plugs, and could technically charge up your smartphone about 6,000 times. It's the largest mobile power bank I've ever seen. We'll need to bolt the exterior I-beams to the frame on site, so we're welding some nuts onto the inside of a steel plate. Then welding that plate to the end of the top tube of the solar frame. It'll be pretty amazing if this all comes together correctly on our first try. The I-beam is what's going to be supporting all of our solar panels, one heavy I-beam on the top of the array and another heavy I-beam on the bottom. Since here in Utah we are quite a bit above the equator, our solar panels all need to sit at a slope to most optimally obtain their solar energy. But that works out just fine since we also want the snow that falls in winter to slide right off. We're using a magnetic drill press, cleverly called a mag drill, to pre-drill the mounting locations for the solar racking. The racking is from a snap and rack ground mount system, since the ground mount rails are slightly more robust and can span longer distances than the roof mounted snap and rack rails, but you'll see those in a second. For cutting the flat sheet, we move over to our own laser here at the wheelchair factory. You'll notice that we use a suction cup hoist to lift the metal onto a deck made of pointy teeth. The teeth and the space between them allows the laser light to liquefy the metal at a specific point, and then the assist gas blasts the molten metal out the backside of the sheet. We use oxygen, nitrogen, or sometimes just compressed air as that assist gas, depending on what needs to be cut. The powder coating process also surprisingly requires electricity. The powder coat itself has the consistency of powdered sugar and gets statically adhered to the metal before getting cooked in an oven to solidify that thick protective top coat. There are over 5,000 different shades of this powder coating dust, even glow in the dark, so we're able to make some pretty fun looking wheelchairs. Finally, the final assembly.
The hardest part of this project is that we are trying to assemble 14 kilowatts worth of solar out in the middle of nowhere. The closest hardware store is going to be about 2 hours away, meaning we only have one shot to do this right. We're going to do a dry fit right now. I don't know, there's probably like 2,000 pounds worth of metal. The battery's like another 3,000 pounds. There's a lot of things that have to line up just perfectly for us to get this right on our first try, which is why we made the whole thing bolt together so everything should connect just like a little Lego.
We don't have enough time to build up bolt arrays, since we literally have to drive out to the flats within the next 24 hours.
It's impressively large.
But long story short, we will have 12 550 watt panels per array.
Alright, we skipped a few steps because the sun is going down, but we do have 4 panels up on the rack already. These are just up there temporarily to make sure that it works. I'm not going to show how we got them up because that's not a good thing to do, but it looks really good. Tyson, get down. What are you doing? I'm working. We are a third of the way there, and then once all the panels are in, hopefully we're cranking out, what would this be, 6,000 watts-ish for this single array. All right, we got this.
Each of the panels will be run in strands of 4, which allows 3 strings to go into a photovoltaic combiner box, and from there into one of the 2 PV inputs on the Komodo. The power tank can be charged with a normal 240 volt plug, but since we're going to be miles away from the nearest wall outlet, we're going to max out the 12 kilowatts of solar instead.
At least now we know the solar panels work. They are facing the wrong direction though, and it is a little cloudy outside, so we're not 100% sure both arrays are going to be functional, but that is a problem for us to figure out at the salt flats. First we have to get everything there. Luckily, disassembling is way easier than assembling. Now the only thing left is paint and loading up the trailers before the sun goes down.
Salt is extremely corrosive, which is one of the reasons why you gotta be really skeptical of buying used vehicles from coastal areas. Usually the frames of those cars are super rusted out from being so near the salty ocean. And since we are setting our tubes right on top of a literal evaporated lake bed of salt, the protective paint should buy us a few extra minutes before things start rusting.
We're cutting this project so close, I think the paint is going to be drying as we're driving our way out to the salt flats. If you are here in Utah, feel free to swing by the salt flats and come check us out. If not, I will have a full video posted in about a week with, whether or not it worked. We have not yet fully assembled the batteries and the solar and all the metal at once, and there's a million things that can go wrong between now and a week from now. Wish us luck down in the comments, and thanks a ton for watching. I'll see you around.